let's go to page 90 and let's do number 84. Okay, it says find the remainder when x to the 13th power plus 1 is divided by x minus 1. So you're looking for remainder. Okay, so for this one, you just need to apply the remainder theorem. So you have x to the 13 plus 1 divided by x to the minus 1. So you can go ahead and there f of x equal to x to the 13 plus 1. And then when you divide by this, you can substitute this into here. So f of 1, like if you solve, you get x equal to 1. We equal to 1 to the 13th power plus 1. So f of 1 will equal to 1 plus 1. So f of 1 equal to 2. Okay? And so again, when you so the remainder theorem is substitution and remainders are interchangeable. So when you substitute, the number you get will be the remainder. So remainder will be equal to 2. Okay, let's go to the next one. Okay, number 85, it says find all the roots of 2y to the 4 minus 9y to the 3 plus 14y squared plus 6y minus 63 equal to 0. Okay, so this is a fourth power, so you're going to have 4 roots. Okay, so first, let's go ahead and find all the possible rational roots of this one. So the factor of this would be plus or minus 1, plus or minus 2. The possible factor of this would be plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 63, plus or minus 21, plus or minus 9. Okay? So the possible candidates for the rational roots would be ratio of this over this. So this over this would be plus or minus 1. This over this would be plus or minus 1/2. This over this would be plus or minus 3. This over that would be plus or minus 3 over 2. Then you have plus or minus 7, plus or minus 7 over 2, plus or minus 9, plus or minus 9 over 2, plus or minus 21, plus or minus 21 over 2, plus or minus 63, plus or minus 63 over 2. So all these are possibles. Right? So let's go ahead and try some of the numbers, and you want to keep track. Okay? But the one that we can know right away is when y equal to 0, okay, you will get negative 63. So that's always a good starting point. Again, remember when you substitute 0 in here, you get negative 63. So that's what you get. Okay, so that's going to use synthetic division. So negative 9, 14, 6, negative 63. Okay. So the first number we're going to try is, let's go ahead and try, because the number is kind of high, so let's instead of start with 1, let's start with 3 and see what we got. Let's start with 1. Okay, just start with 1. Okay, so start with 1. So you drop the number, multiply, you add, multiply, you add, multiply, you add, multiply, you add. Okay, so when you try 1, you get negative 50. Okay, so what we're going to do is we're going to try the next number. Let's go and try 3. So it's getting closer, so we're going in the right direction. Okay, so let's try 3. So you drop, multiply, you add, multiply, you add, multiply, you add, multiply. Okay, so that's kind of nice. So when you try 3, it gets 0. So you got one answer already. Okay. And so what we're going to do is going to continue because we need to check if this is a double root or not. So we're going to continue. We're going to try the 3 again. So you got 2, negative 3, 5, 21. Okay. So we're going to try 3 again. So you drop, multiply, you add, multiply, you add, multiply okay, so when you try 3 again, so once you start this, you kind of start all over again, okay? So when you try 3, you get 63. Okay. So obviously this is not a double root, okay? And again, from here, you can also try 0. Again, if you try 0, see from these, right? So when you try 0, you're going to get 21, okay? So obviously, and also another thing to note is that when all these are positive number, that means this is your max. That means there's no number beyond 3. Okay, so when all these are positive, means this is the max. So it means there's no number beyond this. So we don't try the 7, 9, 21, or 63 because there's no roots beyond this because this is already all positive already. So we need to go opposite direction. But again, when you set x equal to 0, this is the cube, square, x, all this will equal to 0, so you get 21. Okay, so we're going to go to negative numbers. Okay, so let's go ahead and try -1. So you can make sure you keep track of the numbers that you try. Okay, so if you try -1, so you drop, multiply, you add, multiply, you add, multiply, you add. Wait, double check. 2, -2, -5, +5. Oh, this would be a 10. So it would be a -10, and this would be 11. Okay, so you try -1, you get 11. So you're getting closer. Okay, but don't try 2. Okay, don't go -2 because there's no -2 on the list. So you try -1. The next one on the list would be -3. So let's try -3. Okay, you drop first number, multiply, you add, multiply, you add, multiply, you add. Okay, so when you try -3, you get -75. Okay? So there's going to be one answer between here. So the one you try to do is look for the one between -1 and -3. So you go to the list. The number between -1 and -3 is -3/2. So let's go and try that. Okay. So let's try -3/2. Okay, so -3/2. Okay, so you drop the number. Okay, multiply, you get -3. You add -6. Multiply, you get 9. You add, you get 14. Multiply, you get 21. You get 0. Okay, so that's kind of nice. Okay, so we found another root. Okay, so once we find this, now this is we can use the quadratic formula or factoring to solve this. Okay, so you got 2x squared minus 6x plus 14 equal to 0. Okay, so this one is not factorable, so we have to use quadratic formula. So let's go and, but before we do that, let's go and divide it by 2 to lower the number. Okay, lower the number, it's so easier to do. So you got x squared minus 3x plus 7 equal to 0. Okay, so you're going to get x equal to -b plus or minus square root of b squared minus 4ac over 2a. So x equal to 3 plus or minus square root of 9 minus 28 over 2. So x will equal to 3 plus or minus, this will give me -19, so it will be 19 square root of 19i over 2. Okay, so these are your 4 answers. So when you put them all together, your answer would be the 3, -3/2, and 3 plus or minus square root of 19i over 2. Okay. Okay, let's go to the next one. Okay, it says find all the value of m for x plus 2 is a factor of x cubed plus 3m squared x squared plus mx plus 4. Okay, so again, if this is a factor of these, so this divided by this will give you exactly would be no remainder. Okay, and so if you solve for this, the value of the x would be -2. So you want to apply the f of -2 to this. Okay, so it would be -2 to the 3 plus 3m squared -2 squared plus m times -2 plus 4. Okay, so f of -2 will equal to -8 plus 12m squared minus 2m plus 4. Okay. And because this is a factor of this, so the remainder will equal to 0. Again, remember, remainder and substitution are interchangeable. So this is a factor of this, so your remainder will equal to 0. So set that equal to 0, and you simplify. So you got 12m squared minus 2m minus 4 equal to 0. And going to divide by 2 to lower the number. So you got 6m squared minus m minus 2 equal to 0. And this one, let's try to see if it's factorable. So it'd be -1, -12. Okay, so it's kind of nice. It's factorable. Okay. Okay, so m and 6m is not going to work. So you have to do 2m and 3m. So this would be the inside. So it would be +1. This would be the outside. So it would be -2. So from here, when you solve, you're going to get m equal to -1 over 2. This one, you'll get m equal to 2 over 3. Okay, and that's it. Okay, let's go to the next one. It says, find the product of the nth root of 1. Okay. Okay, so you're looking for the product of nth root, roots of 1. So in order to get this root, your equation is x to the n equal to 1. So that's your equation for this. Okay. So that way, when you take the nth root, you get x equal to that. Okay, so we're going to move this over. So you're going to get x to the n minus 1 equal to 0. And so to find the product of all the roots, okay, if you remember your the root theorem, okay, the root equation. So for example, if you start with the square equation, you get x squared minus r1 plus r2, x plus r1 r2 equal to 0. So here is the product of the roots over here. Now for the cube, okay, so here's your product of the roots, okay, but it will depend on the n. So if you go to the cube, it would be r1 plus r2 plus r3 x squared. Okay, so plus minus plus something over here would be x, then minus r1, r2, r3. Okay, so notice that when exponent is even, it's going to be positive. When exponent is odd, your product of the roots would be negative. Okay, so but it's it will be always equal to 1. Okay, and so you're going to have so the product over here is 1. So you can, if you match, it's going to be -1. Okay, it will always -1, but the plus or minus will determined by -1 to the nth power. Okay. And you can check, right? So when n equal to 2, so when n equal to 2, it would be opposite, would be negative. Okay? So it would be negative. So this would be, the product would be negative. So when n equal to 2, so that's correct. So you have to, you can adjust this one to make sure the signs match. And if you multiply this out, this will equal to negative 1 to the n plus 1. Okay? And this would be the product of your roots. Okay, so again from here, when this is even, okay, when n equal to even, when n equal to even, this will give you this, the product will equal to negative. Okay, over here when the n equal to odd, okay, the product, it match exactly, so the product, so this would be the product. Okay, and this one, the product will equal to positive. So this one's going to alternate the signs. So when you work it out, you're going to get these. Okay. Okay, number 88. So x to the 4 minus 16x to the 3 plus 94x squared plus p of x plus q equal to 0 has two double roots. And you're looking for p plus q. Okay, so you have the two double roots, means r1 equal to r2 and r3 equal to r4. Okay. Okay, and if you write the root equation, you're going to have x to the 4 minus r1 plus r2 plus r3 plus r4, x to the 3 plus this part of your x squared minus, so it'd be plus minus plus minus something x plus r1, r2, r3, r4 equal to 0. Okay. And this part over here would be r1, r2 plus r1, r3 plus r1, r4. So again, you take none at a time, one at a time, two at a time, three at a time, four at a time, right? So those are your combinations. And you have R2, R3, R2, R4, and you have R3, R4. Okay? So this is what goes inside the parentheses. Okay. Now again, you apply up here, so R1 equal to R2, and that's going to be equal to A. And you have R3, so R3 equal to R4, that's going to be equal to B. Okay, so by doing this matching, okay, you're going to have A plus B equal to 16. So the negative match with negative and this match with the 16. Okay, so that's equal to that. And so from here you're going to get 2A plus 2B equal to 16. So divide by 2, so you got A plus B equal to 8. Okay, so we got one equation from here. Now let's go and do this equation here. So R1, R2 would be A squared. R1, R3 would be plus AB. Okay, this would be also AB. This one will also AB. This one would be also AB. And this one would be B squared. Okay, and this would match with 94. So this is equal to 94. Okay, so again, so this match that, match this with this. Okay, so now let's go ahead and work this out. Okay, so you got A squared plus 1, 2, 3, 4, so 4AB plus B squared equal to 94. Okay, now to solve these, right, instead of trying to subtract and substitute, okay, let's go and use a trick that we learned from before. Let's go and square this over here. So you get A squared plus 2AB plus B squared equal to 64. Okay, and I'm going to substitute this into here. Okay, so there are 4AB. There you need 2AB, but you have 4AB, so you got 2 extras. So you're going to get 2AB plus 64. Okay, so substitute this into here. equal to 94. Okay, so subtract 64 from both sides. So you got 2AB equal to 30. So you got AB equal to 15. Okay. Now from here, from this 2 over here, so you got A plus B equal to 8. Okay. Now again, because all this should be, so when you just kind of work it out, you can see very, you can just see very clearly that it's going to be 3 and 5. Okay. So you got A equal to 3, B equal to 5. Okay. And from here, again, it doesn't matter if A equal to 3, B equal to 5, or A equal to 5, B equal to 3, because we just kind of assign randomly, right? Okay. So once you do this, okay, and now we can do this part over here, okay. So if you match this part over here, okay, what goes into the parenthesis with, so it be 3 at a time, so it be R1, R2, R3, plus R1, R2, R4, be R plus R1, R3, R4. So this is missing R4, missing R3, missing R2, then you're missing R1. Okay, so that's what goes in here. So, but notice that opposite, right? So now you're going to match this with this. Okay, so you're going to get, I'm going to put a negative P. So negative P equal to R1, R2, R3, plus R1, R2, R4, okay, plus R1, R3, R, okay, double check, okay, R4, then R2, R3, R4. Okay, so now go and substitute all this in here. Okay. So negative P will equal to, so this would be 335, so 3 times 3 times 5 will give you, okay, will give you 45. So again, this is 335, so it would be 45. This is 3, so it would be 355, so it would be 75. And this would be 355, it would be 75. Okay, so again, this is your R1, R2, okay, and this is your R3, R4. So substitute this number into here, you get that. Okay, so you got negative P equal to 240. Okay, you add this together, so P equal to negative 240. Okay, now let's find Q. Okay, the Q match with this over here. Okay, so Q equal to R1, R2, R3, R4. So Q will equal to, so it be 3355, so it be 9 times 25. So Q equal to 225. Okay, so once we find P and Q, we can find P plus Q. So P plus Q equal to negative 240 plus 225, and so this will equal to negative 15. Okay, let's go to the next one. Okay, number 89. Say that f of x equal to ax to the 7 plus bx to the 3 plus cx minus 5, and a, b, c are constant. Okay, so if f of negative 7 is equal to 7, you're looking for f of 7. Okay. So what we're going to do is, since f of x equal to that, that's going to look for f of negative x. So f of negative x is when you replace x by negative x. So the odd number part will give you negative. Okay. So odd number will give you negative, and the odd number will give you negative. So that's what you're going to get. Again, if you replace x by negative x, you're going to have negative x to a 7th power, so you're going to have a negative. You're going to have negative x to a 3 power, you're going to have negative. And x become negative x, you're going to get that. So now you're going to add this together. So you have f of x plus f of negative x equal to, this will cancel out, cancel out, cancel out, so equal to negative 10. Okay, this will give you negative 10. So now we're going to apply this into here. So you have f of 7 plus f of negative 7 will equal to negative 10. Okay, so again, so when you have two opposite functions, will give you negative 10. Doesn't matter what numbers are. Okay, but this is giving, so we can substitute f of 7 plus f of negative 7 is 7. Okay, and then from here we just go ahead and minus 7. 10. Okay, so substitute, and then you minus 7 on each side. So f of 7 will equal to negative 17. And so that's your answer. Okay, let's go to the next one. Okay, number 90. It says for non-zero constant c and d, the equation 4x3 minus 12x to the 2 plus cx plus d equal to 0. It has two real roots which add to give you 0. So you got two real roots that add up equal to 0. And then, well, since this is the cube equation, you're going to have a third root, right? So now since they add up equal to 0, so that means you're looking for d over c. Okay, so since you add up equal to 0, so that means r1 equal to negative r2, the opposite. Okay, so that's what's giving. Okay, now before we apply the root equation, we need to divide by 4. Okay, so let's divide everything by 4, so we can apply the root equation. So from here, you're going to get x cubed minus 3x squared plus c over 4x plus d over 4 equal to 0. Okay. And the root equation is x cubed minus r1 plus r2 plus r3 x squared plus something. So plus minus minus r1, r2, r3 equal to 0. Okay? Okay, so we're going to do the matching. So this match with that, so r1 plus r2 plus r3 equal to 3. And the negative match with negative, so that's nice. But from here, r1 plus r2, they're opposite, so they add up equal to 0. So this part equal to 0. Okay, so this is equal to 0. So that means r3 equal to 3. Okay, so just keep that in mind. Okay, so also we can match this part over here. This part is, if you match it up, this part came from taking 2 at a time, so it would be r1, r2 plus r1, r3 plus r2, r3. And this will match with equal to c over 4. Okay. And since r1 equal to negative r2, r1 equal to negative r2, so these two will cancel out, right? Because they are opposite of each other. So from here you get r1, r2 equal to c over 4. Okay. And if you multiply, you're going to get c equal to 4 r1, r2. Okay, now, so we found c. So now let's go and find d. Okay, so we're going to do the matching for this part over here. Okay, so d over 4. So these match with negative r1, r2, r3. Okay, so you apply the root equation. Go and cross multiply, so d equal to negative 4 r1 r2 times 3, right? r3 equal to 3. Okay, so now we can go and put d over c. So d over c will equal to negative 12 r1 r2 over 4 r1 r2. Now we shouldn't multiply, we should just leave it with this one, cancel out. Okay, anyway, so d over c will equal to negative 3. Okay, and that's it. Okay, let's go to number 91. Okay, number 91, it says the equation with the roots. So you have the 4 roots. And so 4 roots are r1 equal to 3 plus square root of 2, r2 would be the conjugate, right? Would be 3 minus square root of 2, R3 equal to negative 3 plus square root of 2i, R4 equal to negative 3 minus square root of 2i. Okay, and the equation is in the form of x to the 4 plus ax to the 3 plus bx to the 2 plus cx plus d equal to 0. So you want to write the equation in this case. So you're looking for what the a plus b plus c plus d. Okay. Okay, so from here, once we find the roots, right, we can apply the root equation. So the root equation, now instead of doing the whole thing, okay, you're going to end up with the x to the 4 power. Okay. So it's going to be quite messy, so you don't want to do that. So again, if you apply the 4 power, it's going to be very messy. You got all these terms up here. It would be too messy. So we're going to apply the second power to each one. Then we can multiply together. So it's a lot easier. So x squared minus r1 plus r2 x plus r1 r2 equal to 0. Okay. So we're going to apply this to this and apply this to that. So we're going to, instead of do the whole thing all together, we're going to do just half and half. Okay, so for this one, you're going to get x squared minus, you add, you get 6. Multiply, you get 9 minus 2. Okay, so from this side, you're going to get x squared minus 6x plus 7 equal to 0. Now you apply it to this part over here, you're going to get x squared minus, you add, you get negative 6, you multiply, okay, you're going to get 9 minus 2. Now I squared is, the I squared is negative 1, so this becomes plus 1. Okay, so you're going to get x squared plus 6x plus 11 equal to 0. Okay. Okay, so these two roots came from this part. These two roots came from this part. So now when you put all this together, your equation is x squared minus 6x plus 7 times x squared plus 6x plus 11 equal to 0. Okay, so now all you have to do is just go and multiply out. So you have x to the 4. So again, you go and multiply. So this multiply, you get x to the 4 plus 6x to the 3 plus 11x squared. Then you go to the next one, minus 6x squared, or cube. Okay, minus 36x squared, minus 66x. Then you go to the next one, so it would be plus 7x squared, plus 42x, plus 77 equal to 0. Okay, so simplifying, so this will give you x to the 4, and the cube part, this one and this one cancel out, so that's kind of nice. So the square term, this one, this one, this one, will give you plus, so 18 minus 36 will give you, okay, would be minus 18 x to the square, and so this one and this one will give you minus 24x. This one, yeah, okay, 24x, and then you get plus 77 equal to 0. So from here you can see that the a equal to 0, a is for the cube term, b equal to negative 18, c equal to negative 24, d equal to 77. So a plus b plus c plus d equal to, you add all this together, you give you 35. Okay. Okay, now, so this is kind of long, but there's a quick way, there's a shorter way of doing this. Okay. So if you set this equal to f of x, okay, so f of x equal to x to the 4 plus ax cubed plus bx squared plus cx plus d equal to 0. So if you look for f of 1, so f of 1, so all this will become 1. So become 1 plus, this would be 1, so it would be 1a. So again, all this would be 1. This would be 1. Okay? So f of 1 will equal to that. So now you also apply the f1 to this. Okay? So again, let the f of x equal to this. Okay, so equal to x squared minus 6x plus 7 times x squared plus 6x plus 11. Okay, and again you apply f1 to this. So equal to 1 minus 6 plus 7 times 1 plus 6 plus 11. So f of 1 will equal to 2 times 18. Okay, so f of 1 will equal to 36. Okay, so now we're going to equate these two. Okay, so you got 36 equal to 1 plus a plus b plus c plus d. So minus 1 on both sides. So you can see 35 equal to a plus b plus c plus d. Okay, so you can, this is another way of doing this. That way you don't have to multiply out, with a long equation, then you have to simplify. So either way,